Hello, I'm Ghazal Kharouk from grade 11 AG and I'm working on this project with Massa Al-Sam from also grade 11 AG, and this is the Vectors project, term 3. Now there are some questions that I have to answer first of all. What is our project's goal? The goal of our project is to explore and understand vectors. Vectors are a way to represent quantities that have both direction and magnitude, like force and velocity. And by studying vectors, we can learn how to use them in various fields such as physics, engineering, and computer graphics. The second question is, what does vector mean? Vector is like an arrow that shows both direction and size. It tells you which way to go and how far to go. And the third question, which is, explain the concept of components and magnitude in vectors. Components basically mean components. You have to think of a vector as in an arrow that can be split into smaller arrows that shows how far it goes in different directions, like up, down, left, or right. Magnitude. The magnitude is just the length of an arrow. It tells you how big or strong the arrow is. Last thing, what is the two methods of vectors? You have two simple methods, which is number one, tip to tail method. You have to place the tail on the starting point of the second vector and at the tip of the first vector. Then draw a new vector from the tail of the first vector and the tip of the second vector. This new vector is going to be the sum. And the second way is component method. You break each vector into its horizontal, side to side, and vertical, up and down parts. Add the horizontal parts together and the vertical parts together. Then combine these sums to get the new vector.
First of all, we created a word problem that includes two vectors, which are A and B, that have a specific angle. Okay, so we found the components of A and B given the initial point of A and the terminal point B. Okay, so the first force we used was 300 newtons with a 30-degree angle above the horizontal. And for B, we worked with a force of 400 newtons horizontally to the right. We found the components of A and B. As we know, to find the components of A and B with a given angle, we're going to use the cosine and sine rule. Okay, we're going to say 300 cos 30, cos, which stands here for x, we're representing x. We got 259.81 newtons. And for the vertical components, we got 300 sine 30, sine our angle. And we got 150 newtons. Okay, so since workers B force is purely horizontal, the horizontal component is 400 and the vertical is 0 newtons. Okay, and here is our components of A and B. We got 695.81 and 150 newtons. We just used the normal component formula. Next, we found the magnitude of the vector, which is the resultant force. We used the normal formula of the magnitude, which is V equals square root A to the power 2 plus B to the power 2. Okay, we just substituted. I didn't write the formula because it's very obvious and I just mentioned it. And we found that the magnitude used was 676.49 newtons. Next, find 3a plus 2b. It's literally so easy here. We just substituted. We got 3a. For 3, we just multiplied 3 by the components. We found a and we found b. So we multiplied 3 by a and then we added and then we multiplied 2 by b and then we added them together to get the final result of the two vectors, which was 1579.43 and 450 newtons. And these were our components of the two vectors. And okay, now let's answer the following questions. First of all, A, what is the sum of the horizontal components of the vectors? What is the sum of the vertical component? As I explained in the first place, the sum of the horizontal component is basically the sum of the horizontal force. We got 400, as I mentioned before. We use the normal rule. I said 400 plus 300 cos 40 newtons, and for the vertical we just did 300 sine 40 newtons. It's pretty easy, pretty simple. What is the resulting force on the tree? The resulting force on the tree was calculated by the Pythagoras theorem, as I mentioned before. It's just the same questions repeating. I explained them before. And for part C, would changing the angle of the tractor affect the magnitude of the resulting force if the angle between the tractor remained 40? Changing the angle would not affect the magnitude. That's like the full summary, because the horizontal and vertical components of the force are independent of the angle between the tractors. As long as the horizontal and the vertical force remain constant, the magnitude of the resulting force remains the same. So the angle only affects the direction of our resultant force. It does not affect the magnitude.
Okay, now the second part, which is the simulation. So this graph is for our word problem. I got A as 17.2 because I divided 259 by 15, and I got B as 15 because I divided 150 by 10. I here have the sum turned on, which is 14.9. I have the values turned on, and I also have the angles showing. Now for the second part, which is 3a plus 2b, I got A by dividing 779, which is 3 times 759 by 52 to get 15. And I got B as 7.1 because I divided 300, which is 2 times 150, over 42, and the answer is 7.1. Now, for the reflection part, I think that, in my opinion, I prefer the simulation part more than the manual, because it just is more accurate than me sketching, drawing, and measuring. Also, it's so much easier because you can just put the values and it will give you the correct and accurate answer. Thank you so much for listening. I hope you enjoyed our project presentation.